Warm good evening to all once again. I welcome you all to the live session for Advanced Concrete Technology, a week 3 problem solving session. I hope I'm audible to all. Okay.
Yes.
I am Nilakanmani. I am a PhD student from Indian Institute of Technology Madras, and I'll be one of the TAs for solving the problem solving sessions. So every Monday and every Tuesday there will be a problem solving session. I'll be handling the Monday problem solving session. Last week, due to certain situations, I was not able to handle the session, and from this week, you guys will be having a problem solving session on Monday as well from 6 to 7. Okay, let's move to the first question for week 3 content. So I expect you guys to watch the videos for week 3 content and then come for the live session, so that you will be able to answer the question in the polls um, or in the chat box. Okay, before getting into the questions, let me introduce you guys to the option called polls in the Google Meet. So here to the bottom right corner of your screen, there is an option called activities. Okay, if you click that, there will be a triangle, square, and a circle together. If you click that option, you will find an option. You will find 4 options: breakout rooms, polls, Q&A, whiteboard. Out of that, you have to choose polls. Okay, already 2% have given your answers. Nice, thank you. So here you can find the questions. As of now, you can answer the questions for which I am discussing. Progressively, you can give the answers for the following questions when we discuss. Thank you. If you have any difficulty in finding these polls, if you're using a mobile phone, then there will be 3 dot in the screen, right? If you click that, you will find there will be more options. In that, you will find activities. Okay. I hope it's clear for everyone to how to give your answers in polls. Okay then. So the first question is, smaller cement grains which are partially hydrated on the outside, uh, leaving behind an empty shell are called. So this is the question. So I have given 4 options for you guys. So it's Portlandate crystals, or it's unhydrated cement grains, or it's called hardly grains, or none of the above. You have to pick any one option and give your answer in polls. If you guys are not able to give your answer in polls, you can enter your answer in chat box. Let me wait
Hardly
for.
grand.
Yeah, hardly can is the right answer. Better don't say the answer in the Google Meet, so that the person who are willing to answer, it might be a disturbance for them as well. It's really nice that you guys know the answer. Let me check the polls right now. Okay, some people have given answer in the chat box as well. Yeah, most of you have opted for hardly grains, and 1 or 2 have given some other answers as well. Okay, let's see the explanation. So if like mostly these hardly grains are formed with very small cement particles. If it's very small, then automatically it will undergo fast dissolution, ready dissolution. Okay, so what happens is the inner grain, like completely this whole region will undergo dissolution, so there will be no inside region for this grain, so it will be hollow, it will be empty, and there will be fibrous CSH particles formed on the outside surface of the grain. So it looks like a hollow shell. Outside there will be fibrous CSH grains, and inside it will be hollow. It's called hardly grains, and it's named after Hartley, who worked with Diamond, who worked in Purdue University, USA, and then they both worked in cement chemistry. So after him, it is named as Hartley Green. Okay, then let's move to the next question. If you guys have any doubt, you can put it in the chat box or you can unmute yourself and ask the question. Okay, then. Here is the question 2. I have given you two statements. Okay, statement 1 will be there and statement 2 will be there. So you have to find which statement is true and which statement is false, or if both statements are true, then you have to give your answers as such as given in the options. So statement 1 is inner CSH is less denser than outer CH. This is statement 1. And statement 2 is outer CSH has more pores than inner CSH. So I've given you two statements. So, and I've given you four options to pick. As per option A, statement 1 is true and 2 is false. And as per option B, statement 2 is true and 1 is false. And as per option C, both statements are true, and option D is both statements are false. You have to pick your answers from polls. So I know you guys won't know the difference between inner CSH and outer CSH. Unless you know the difference, it will be difficult to answer. CSH is nothing but calcium silicate hydrate. So once cement hydrates, CSH, Portlandite, that is calcium hydroxide, Ettringite, AFM phases will be formed. So I'm asking you to find the difference between inner CSH and outer CSH and choose which statement is true and which statement is false, or if both statements are true or false, then you can pick the options as such. Let me wait for a minute, then we'll check for answers. Let me end the poll for question 1. Okay. So to the people who joined recently, let me explain the option called polls. So to the bottom right corner of your screen, there is an option called activities. If you click that, there will be 4 options. You can pick then you can pick your answers here. Sorry, then you can pick polls. In polls, there are few questions launched, so you can give your answers. As of now, you should give your answer for question 2. If you guys are not able to, I request everyone to mute yourself. Prashant. Yeah, thank you.
Mute it.
Yeah. Okay, there is mixed response for question 2. If the question is not clear, so statement 1 says inner CSH is less denser than outer CSH. Okay, and then statement 2 says outer CSH has more pores than inner CSH. Okay, let me open the chat box as well. Okay, option B. Okay. Option C as well. Okay. Let's see. I hope enough time has been given for question 2. Let's move to the explanation part. So still there are around 20 people in the class and I could see only 8 people have given their answers. It's very simple. Your name will not be revealed who has given which answer. So please give your answer in polls, okay, so that you will find, so that you will understand. Once you participate in answering the question, it will be easy for you guys to follow the class. Okay. So So here is this is one of the snap from the lecture. So here they've given the difference between inner and outer CSH. So inner CH is also known as phenograne and outer CH is called as ground mass CSH. Okay, because when see outer CH in the sense it will be formed on the outside of the grain. It undergoes dissolution from the surface of the grain and then it undergoes dissolution. It forms hydration products on the outer side. So it's called outer CSH. Inner CSH on the other hand, so this is this outer CSH, which is in the ground mass. And what is inner CSH is, so once this outer CSH is formed, then water tend to diffuse through this cement grains, unhydrated cement grain, and form the reaction product on from, like it's called topochemical reaction. It forms from where it is. It does not move, or the water diffuse from the outside to the inside, and then it forms hydration products. So that is called inner CSH. It's called phenograne CSH as well. So it is very dense because once it in outer CSH it undergoes diffusion, uh, the the calcium, silicate, and all, it undergoes dissolution from the surface and it forms hydration products on the outer side. So it will be very porous. So it has more pores and compared to the inner CSH, and it contains less alumina and silica because mostly in cement we know that calcium alone as the more calcium as the calcium is the amount of calcium present in the cement composition is higher. So obviously inner CSH has less alumina and silica, and then sorry sulfur, and compared to the outer CSH, and then it forms larger grains and it forms with smaller grains. Outer CSH. Hello. Hello. Yes. Uh, I can't hear you properly. Okay. If you have any doubt, please type in the chat box. After this question, I will check the chat box as well. Thank you. So, which means the first statement, inner CSH is less denser than outer CSH is not true, because outer CSH is less dense. Okay, then outer CSH has more pores than inner CSH. Yes, outer CSH has more pores. So obviously statement 1 is false and statement 2 is true. Okay, for this question there are more mixed response from the class. So I hope you guys got it clear now. So the correct answer is option B. Let's move to third question now. Before that, let me check the chat box once again. Okay. If you guys have any doubt while discussing or after discussion, or even let me try to finish the class at least 5 to 10 minutes earlier, so that last 5 to 10 minutes we can keep for discussing few questions. Okay. Fine then. Let's move to question 3. So the question 3 is, durability is much governed by outer CSH than inner CSH. This is a statement. Okay, this is a proper statement. They're asking the reason why it is so. Durability is governed by outer CSH than inner CSH. Why so? There have been 4 options. Option A is inner CSH is less denser than outer CSH, and then option B is outer CSH has more interconnectivity of pores, and option C is both option A and B, and option D is none of the above. Please give your answer in polls so that we have a gross response from the class, either you guys understood the question or not. To the people who joined very recently to the class, let me explain how to use polls. So to the bottom right corner of your screen, oh, oh, there is some issue in the, yeah. Prashanta, please mute yourself. Yeah, thank you. I think there is some connectivity issue from my side. I hope now it's clarified. Yeah. Let me end the poll for question 2. Okay. Around 9 people have given your answer for question 3. Okay. Durability is governed by outer CSH than inner CSH because. You should find the reason. Correct reason. Okay. More votes for option B. Okay. Let's see which is the right option. There are around 20 people in the class and only 10 people are actively participating in giving your answers. More than chat box, polls, your name will not be revealed. So please give your answer in polls so that it will be easy for you guys to follow the class as well. Okay. Okay, then let me end the poll for question 3 and move to the explanation. Okay, then. Uh, So here is the question: durability is governed by outer CSH and inner CSH because. You have to find the reason. So the correct answer is outer CSH is more inner connectivity of pores, because in the last question itself I've shown here that uh, outer CSH is more pores. Okay, so there will be more interconnectivity of the pores as well. Because of that, when there is when there is porosity, durability will be affected. But when there is more interconnectivity between the pores, then durability will be much affected. So obviously durability is governed by the interconnectivity of pores. So option B is the right one. So this question 4 is not launched in polls. You have to give your answer in chat box. Okay. So the question 4 is you have to pick the statements which are all true. Okay. Yeah, so this particular question is more than one option, so you have to find the correct one. So they have given around 6 options. Out of that, you pick the right one. Option A is the progress of cement hydration depends on rate of nucleation and crystal growth of hydrates. That is option A. And option B is gel water is a sum of interlayer water and capillary water. If you know gel water, then you should know what is which makes up the gel water. Then option C is the form of gypsum in the cement influences the hydration rate. Okay, so we know that gypsum is a set controlling agent. So does really gypsum will affect the hydration rate? Then you have, if it is so, then you have to pick the option C as well. But if it is not so, then you have to leave it. Option D is considering the pore solution composition in blended cements, The unhydrated silica presented in fly ash and slag traps the alkali ions, reducing the ionic concentration in pore solution. Okay, then option E is the sulfate and chloride ions are present in pore solution after 1 week after 1 week of hydration, a typical cement paste. Then option C, F is flash set occurs in presence of large amount of gypsum. Okay, if you know what is my flash set, then if you know what is the role of gypsum, It's a set controlling agent. If gypsum is present, will flash set occur? If it is so, you have to pick it up. If gypsum is present and in the cement, and will flash set really occur on hydration? You have to think it, and you have to pick only the correct statements. Okay. Let me copy this question and post in chat box as well. Sorry. Oh. Okay, some people have already posted A, C, D. Okay, let's see what is the right answer then. Oh, nice. I could see few responses. Oh, I could not copy properly. Okay, just a minute. I have posted the question in chat box as well. Okay. Okay, most of the people have given the right answer. And still, only 3 to 4 people have given an answer. Let me wait for one more minute. Okay, then let's move to explanation part. So we all know that the cement hydration, means the process of cement hydration is happening. So it depends on rate of nucleation crystal growth. Obviously, it depends on the cement hydration depends on the rate of nucleation crystal growth. If there are more nucleation sites for cement hydration, then the cement hydration will progress fast. So obviously, this first statement is true. Then option A will be there, and option B is gel water is the sum of interlayer water and capillary water. Is it so? It's wrong, right? Gel water is the sum of interlayer water and adsorbed water. It's not capillary water. So option B will be ruled out. It's false. Then coming to option C, the form of gypsum in the cement influences the hydration rate. Yes, because there are different forms of gypsum, right? Calcium sulfate dihydrate, calcium sulfate hemihydrate, calcium sulfate anhydrate. All these types of gypsum will affect the hydration rate. So option C is also correct. Coming to moving to option D, considering the pore solution composition and blended cements, The unhydrated silica presented in fly ash and slag traps the alkalis, sodium as well as potassium ions, reducing the ionic concentration of the pore solution. This is true because what the silica particles from the fly ash as well as slag trap these alkalis and then reduce the ionic concentration. That's why addition of this fly ash and silica is helpful in a certain type of chemical attacks, because the addition of fly ash and slag traps these alkalis, so that it helps with the chemical when it comes to chemical attack, certain types of chemical attack. So addition of fly ash and slag is beneficial in this way. And then option E is so option D is true, option A, C, D are true, and option E and F is false, because gypsum is present then flash set will not happen, because gypsum is added to avoid flash set. So that is one. And then option E is normally if it's a typical cement, then the amount of chloride and sulfate will be very less when if it's not a contaminated one. So option E is also false. So the correct answer is option A, C, D. The people who have answered are given the right answer, and rest of the class have not answered. Okay, now you guys got it right. I hope so. Moving to question 5. Which of the following statements are false? This question I've launched in polls. Please give your answer in polls. There are 4 options. Out of that, we have to pick the wrong one. There is one wrong statement here. Let me read out the all the 4 options. Option A is silica content is higher in pore solution for fly ash or slag blended cements. That is option A. Option B is CSS gel as or randomly oriented sheet present in Feldman-Serida model. Okay, as per Feldman-Serida model, Feldman-Serida model, how CSH is it randomly oriented sheet like structure? That is option B. And option C, CSH is present as white trim around aggregates in micrographs from BSE imaging, from SEM image, backscattered electron image. And then option D is removal of free capillary water does not cause shrinkage shrinks. Is it so, like if free capillary water is removed, removal of water means there is reduction in the volume, then obvious shrinkage will occur. But here the option given is removal of free capillary water. So does removal of free capillary water does not cause shrinkage shrink? If it is true, then it's okay. If it's false, they have to pick option D. So we have to go through all these options and give which statement is false. Let me give you some time to give your answer in polls. Okay, few people have given an answer in chat box. Okay, option C. Okay, okay, most of the people have picked option C. Okay, let's see what is the response from polls.
Please show the question again.
Okay, just a minute. I'll show the question again. You can see the question in polls as well. If you're using a mobile phone, there will be 3 dots. If you click that, you can find the option called activities, and in that you can find polls. You can find the question. Okay. Now let me check your answers in polls as well. Okay. More votes for option C, but you are given answers for option A, B, C, D as well. Okay. Let's see which is the right answer. So the correct answer is option C because see, silica content obviously it will be higher for pore solution for fly ash and slag based cements because obviously fly ash and slag will have more silica in its composition. Okay, so obviously silica content will be higher. That is true. And then option B is as per Feldman-Sereda model, CSH is a randomly oriented sheet. So that is also true. And removal of free capillary water means removing the free capillary water does not cause shrinkage because removal of water from gel water and then gel water only it causes shrinkage. Capillary water will not much result in shrinkage strains. Okay, because it does not cause any strain in the pores because the pore size will be larger compared to the gel pores. So that is also true. Only option C is false because the white rims around the aggregate. What is the white rims around aggregates from BSc image? Can anyone answer unmute? Can anyone unmute and answer? What are those white rims around aggregates? If you watch the lecture, it will be easy for you guys to answer. Okay.
Calcium hydroxide.
Yeah, it's right. Calcium hydroxide is the right answer because around the aggregates there will be more space due to wall effect, and because of that there will be more space for the calcium hydroxide crystals to grow. So calcium hydroxide will be the right answer, and CSH will not be present. Will not be present. Most of the cases, the white rims on aggregates will be calcium hydroxide. Thank you. Thank you for being active in the class. Let's move to question 6. You have to arrange the following in increasing order of size. So, it's going to be capillary voids, unhydrated cement. There are totally 4 entries here. Capillary voids, unhydrated cement, entrapped air void, and then entrained air bubbles. So, these are the 4 entries here. You have to arrange them in the increasing order of size. Okay, let me give you guys a minute time. Now the time is 6:36. Let me wait till 6:37 so that then we can see the answer. What is the answer for the question? You can give your answers in polls. If you guys are not able to give your answer in polls, then you can give your answer in chat box. Okay, 1 minute over. Let's see what is the correct answer. So I've given here a snap from the lecture. This you can find in the lecture notes. So oh, there is some issue with my system today. Okay, so here you can see what is the size range for each particles here. Here they have given the size range for interparticle spacing. between CSH sheets, and then that lies in the range of 1 nanometer, and then capillary warts lies in the range of 0.1 micrometer, and then hexagonal crystals of calcium hydroxide crystals lies in the range of 1 micron meter, and then entrained air bubbles lies in the range of 100 micron meter. Entrapped air void will be in the range of 1 millimeter. Okay, so from here we can say that capillary voids is the least sized one, and the non-irritated cement particles will usually lie in the range between capillary voids and the this CSH aggregation of CH particles. So usually it will lie in between this region. So followed by capillary voids, it will be unrated cement particles. Then followed by this, obviously entrained air bubble will be there. Then after that, entrapped air void will be there. That is the size range. So the correct answer is option D. Let me see what answers you guys have given in polls. Okay. Okay, more answers have been given as the correct answer. Okay, fine. Let me end the poll for uh, question 6. Now let's move to question 7. So question 7, you have to give your answer in chat box. It's not posted in polls. Okay. So you have to match the following. What is made ground CSH is nothing but inner CSH. Sorry, outer CSH. Ground mass CSH is nothing but outer CSH, and phenogreen CSH is nothing but inner CSH. As discussed in question 1 or 2, I am not so sure. So when ground mass CSH will be formed? So then you have to match the correct one, and when phenogreen CSH will be formed. I have explained this in question 1 or 2, I suppose. And then what is which crystals will be in the shape of which crystals will be formed in the shape of hexagon? So that also I've already discussed in class. And then which hydrate will be of acicular shape, acicular. And then option 5 is coarse porosity due to high pressure steam curing. What will be the outcome like when coarse porosity due to high pressure steam curing is formed? You have to match the terms in the left side to the right side of the column. Let me wait for a minute. Now the time is 6:42. Let me wait till 6:43 and check for the answers. 1 minute over. I request everyone to mute yourself unless you have doubt. Please unmute and ask question, or else please mute yourself. Okay. Few people have given their answers. Okay. Let's see which is the right answer. Answer is B. No, this match the following.
Ma'am, please show the question.
Okay. Okay. Let me then put the question. Okay, time is up. Let's see the explanation for this question, answer for this question. So this is the answer for question 7. Let's see how many of you have got it right. So coming to ground mass CSH, the correct answer is option C. It's nothing but outer CSH. Okay, outer CSH will be formed with the fine grain, smaller grain. So option C is right. And then for option, then it's phenograne CSH. For phenograne CSH, it's nothing but inner CSH. It will be formed with the larger grains because some part will be undergoing diffusion from the outer side, forming outer product, and obviously the inner part will be remain unhydrated. So after some point of time, water will diffuse through the outer product and reach the unhydrated grain and form inner CSH. Okay, so obviously inner CSH will be formed mostly associated with larger larger grain sizes. Okay, then obviously we know Portlandite is hexagonal in shape, so 3 is nothing but option hexagonal crystals will match with Portlandite. And coming to acicular, ettringite shape is acicular, so obviously option 4 goes with 4 goes with option E. And then fifth one is coarse porosity due to high pressure steam curing is nothing but outer CSH, because mostly due to high pressure what happens is it will undergo ready dissolution. Okay, due to high pressure high temperature curing and all, it undergoes ready diffusion. Obviously outer CSH will be the major hydration product when it comes to steam curing. So with coarser porosity. So is there any query with question 7? Okay, so the correct answer is 1C, 2D, 3B, 4E and 5F. Okay, then let's move to next question. Question 8. Question 8 is very simple and very direct. I hope if you guys have followed week 3 content, then you should give the right answer for this question. Reducing the water to cement ratio in cement paste results in. Okay, what phenomena will be the result if we reduce the water to cement ratio? If you reduce the water to cement ratio. So there are 4 options. I have launched the question in polls. Please give your answer in polls from activities. If you guys are not able to do that, then please give your answer in chat box. Okay. So the option A is reduction in strength of the hardened cement paste, and option B is reduction in porosity. So and then option C is increase in porosity, and then option D is none of the above. Okay. What will the phenomenon resulting on reducing water to cement ratio? Reducing the water to cement ratio will reduce the strength, or will it reduce the porosity, or will it increase the porosity? Okay, please give your answer in chat box or polls. Let me wait for a minute and then we'll discuss the answer. Okay, time is up. Let's see what answers you guys have given in polls or chat box. Okay, option B. Okay. Okay, I hope everyone, most of you have given the right answer. Let me check in polls once again. Okay, more people have given option B. Okay, option B is the right answer because uh, as per in the poll first, share the screen again. So reducing the water to cement ratio will obviously reduce the porosity, and reducing water to cement ratio will increase or decrease the strength. Can someone unmute and tell?
Increase.
Yeah, increase the strength because it will once porosity is decreasing, obviously strength will increase. Okay, so the correct option is option B. Now let's move to question 9. So this is a direct question from a particular snap from lecture. So you guys have to label all these parts. What is like here? There is some dark spots here in the screen. Okay, let me. So this is a backscatter electron image from the lecture, which was explained in the lecture as well. So you guys have to label it properly. Okay. So here there are some dark spots. Okay. So that is A. You have to label A, what is mean by A. Okay. In the chat, please type your answer in chat box. What is mean by A, B, C, and D. And B, here you can find there is a white circular dot, and followed by there is a gray area around it, and then C is a bright white area, and then D leads to a white mass uh, intermixed with the ground mass as well, but it points out the white color mass. Okay, so let me wait for a minute. Please type your answer in chat box. Then I'll ask someone can unmute and tell the answer. And then we'll finally check the answer in chat box. Okay. Okay. Around a minute has passed. Okay. Someone can unmute and tell the answer. What is the dark spots here, which is marked as A? Can someone unmute and say?
These are the pores.
Okay, yeah. Because pores, when it comes to backside electron image, the particle which is very denser will be shown as a bright phase, and which has very less density will be shown as the dark one. So obviously pores will not have much density, so it will be shown as the dark spots. So which means the pores. Okay, coming to option B, what is option B? What is part B? It is very next to the white circular region in the middle, but it points out to the gray space very near to the white region.
Sand,
Yeah?
sand or
No,
silica.
no. Sand will be of a uniform gray structure. This is sand. Okay.
Okay.
Here, yeah. There is some change in the gray zone as well. So here there is some white circular region. Around it there is some gray region. And
CSH.
the, sorry?
Inner CSH.
Yeah, inner CSH, because this white region in the middle points out to the unhydrated cement grains, and then very next to the gray area will be obviously will be the inner CSH. Okay, so what is the part? Then what is option C?
Unhydrated cement.
Yeah, unhydrated cement grain. So
Unhydrated cement.
yeah, unhydrated cement grain. That is the right answer. And what is the white mass around here and pointed by option D?
Outer CHS.
Yeah, it can be outer CSH, but if it's pointed towards the white region there, then obviously it can be uh,
Hydro
Portlandite crystals as well,
Yeah,
silicate.
calcium hydroxide.
calcium hydroxide. Yeah, yeah. But if it's pointed towards the gray area, obviously it can be Ettringite even or outer CSH. Anything can be possible. Unless we do a proper chemical analysis, we can't say that it's outer CSH or ettringite or monosulfate phases. But if it's pointed towards the white region there, then it is obviously fine Portlandite crystals formed around the fine aggregates, space found in between the fine aggregates. Okay, then this was the last question for this week, and tomorrow also you guys have one more live session. It will be handled by one more TA. Okay, if you guys have any more doubt, please unmute yourself and ask.
Madam, I chat one question.
Yeah.
Please answer. Please answer me. I chat one question in chat box.
Okay, let me see the chat box now. But your question should not be from the current assignment, okay?
Okay.
Okay, you have posted a problem, right?
Yes, yes, yes.
See, like if it's going to be a problem, then obviously I have to explain it from the first stage. Then I can't explain you properly. Let me do one thing. Maybe in the next class, I'll take the first 15 to 20 minutes for the problem. Okay, so I'll copy this problem and keep for myself.
Yes, yes.
Okay, you're asking how to calculate volume L force and value of P. Okay, I think this is same as the problem what sir has discussed in the lecture, right? Yeah, yeah. Obviously, we need 23 grams of bound water, and then in addition, we need some more water for the gel pores as well. So, if we don't have 42 grams of water, then obviously some portion of cement will remain unhydrated. That's why we consider P grams of cement only hydrates, not the whole cement hydrates. And then you have to there will form two type of equations. Okay, two equations, not two types. So two equations will be
Yes,
formed.
yes.
If we solve the two equations, then we'll be able to calculate the volume of gel pores as well as the value of P. Okay, let me try to solve this question in next class. Let me take the initial 10 to 20 minutes, then let me solve the problem.
Okay, okay.
Since the current assignment doesn't have any problem, I didn't take anything. Yeah, any problem for this class. Does someone have any other doubt? Let me stop sharing now. Is there any query?
Ma'am, I have the one query.
Yeah.
First of all, 23 gram needed for 100 gram cement hydration.
No,
After
no, not
that,
for
90
hydration.
gram.
Not for hydration. It's for the bound water.
Okay,
Yeah.
but 90 ml after the gel pours. So how it is 90 ml coming? This calculation I have not find out.
You're also having the same query from the lecture, right? Okay.
Yeah, ma'am.
Next class, I'll let me solve the problem which he has stated. 100 grams of cement with 30 grams of water.
Next class timing, madam?
Next class, yeah. See, every Monday and Tuesday, 6 to 7, there will be a live session.
Okay, okay.
Okay. In like tomorrow, there will be one more TA handling a live session. But I am saying whatever happens in next live session, I'll be explaining the same problem uh, in next Monday. Next Monday date is 22nd August. I'll be handling the problem. I'll be solving the problem. Second problem in which the sir has discussed two problems in the lecture, right? I'll be discussing the second one because first one is quite easy. I hope so. So let me solve the second problem for the initial 10 to 15 minutes. Then I'll be moving to the problem solving session.
Okay, okay.
Yeah. Last week Monday session was cancelled due to some uh, situations, but from this week every session will be handled properly. And tomorrow we have one more live session which will be handled by the professor. So please try to attend tomorrow's live session with professor. I think you guys have received the mail with timing. Tomorrow, Professor Manu Santanam will be available for a live session. This 6 to 7 session is separate. That is problem solving session by TAs alone. But tomorrow there is one more live session. Please check your mails regularly and then please attend tomorrow's live session in which Professor will be answering your questions, your queries.
Okay.
Okay then. Thank you all. Let me end the live session now. Thank you for all your patience.
Thank you, ma'am.
Thank you all.